All right, so we are going to solve some literal equations. All right, and by literal equations, it's actually a phrase that I heard only after I started working here. But I've done these many, many times. It is the basis of whether or not you really truly understand how to solve equations. All right, it's a great way to really test to see how much you understand as opposed to just do. Literal equations are just equations with a lot of variables, right? A whole bunch of variables in it. Um, that's just not good right there. Let's get rid of that. In fact, I'll just say with many variables. And in this equation that has many variables, I'm going to ask you to solve just one. So solve for one of them. All right. Let me just go ahead and do a very basic example. What if I gave you an equation that said A is equal to 2 times B? Now, as it stands right now, it's already solved for A, but what if I want you to solve it for B? So this has like an application in science. You'll deal with some of this in some of your science classes as well. Well, regardless of what's there, if you're trying to solve an equation, you still do the exact same thing. You simplify if you can, and then you need to try to use inverse operations to isolate the variable. In this case, the variable we're trying to isolate is B. So I need to get rid of this 2 right here. Well, this 2 is being multiplied, so in order for me to get rid of it, I divide it by 2. If I do it to one side of the equation, I must do it to the other side of the equation. I'm saying it like that on purpose. I need you to pay attention to the fact that we're doing the whole side on these things. Well, on the right side, those 2's are canceled, leaving me just at B. On the left side, I have A divided by 2. I don't know what A is, so you can't give me any other value of it. It's just A. And so B is equal to A over 2. All right. I'm going to make that a little smaller, and I'm just going to keep going and do another. Ooh, not that small. Do another example just to kind of make sure it's a little more concrete. Actually, I'm going to do 2 videos on this now I'm thinking about it. What if, for example, stay put. What if, for example, I use that same equation or similar equation, A is equal to 2/3 B. All right, the idea is still the same. I'm multiplying by 2/3 here. Oh, you don't know which one to solve for, so let me tell you. Solve for B. I need to get rid of this 2/3 right here. This thing right here. Let me move that out of the way because I'm going to use some more space here. So I'm going to say 4B over here. I'm trying to get rid of that 2/3. Now, if you remember this word reciprocal, and if you do remember that it's just a flip of something, if you multiply something times its reciprocal, you get 1. So if I had, for example, over here, 2/3, and I multiplied it by the reciprocal, which is just the flip of it, if I multiply those 2 together, I would get 6, 6, which equals 1. Right? So one idea when I have fractions here is to multiply this side by the reciprocal, 3 over 2. But if I do it to one side, I must also do it to the other. All right, looks kind of messy. What I'm really doing is trying to get rid of this thing. So when I multiply that 2/3 times that 3/2, I get 1B, basically because of this right here. On this side over here, I'm just going to multiply 3/2 times A. That's a very weird looking 2. Now I can rewrite this to make it look neater because 1B is really just B. And then this is still just 3/2 A. Answer. All right, so let me erase this over here so I can get some space. And I think I might be able to squeeze one more in. For example, what if I did area equals base times height? Well, if I solve this for B again, I divide both sides by H. Area